I can start now. Okay, to talk about the formation of ions, you will need to know certain things first. Okay, so take a look here at my slides. Can see my slides? If you can, give me a thumbs up. Good. Okay, so for mathematics, Nikki, correct. Mathematics, many times they split the paper. Okay, but for science, this is the first time I heard of this thing lah. Okay, for lower secondary, usually no. It happens for upper secondary only. Never knew that science has two papers, right, Nikki? Correct. So look at my slides. We are talking about stable noble gas configuration. Okay, what is the meaning of stable noble gas configuration? Right. Noble gas is actually referring to the group of elements. They are in group 18. If you refer to your periodic table, do you have the periodic table? Yes? Okay, have it, take it out. Make sure you can refer to it while I am going through with you. Okay, so try to have your periodic table with you. Then we can discuss. So if you are looking at group 18 now, okay, do you see that there are a few elements there? Helium, neon, argon, krypton, xenon, radon, and the last one, let's see, last one. Oh, my eyes not so good. Organism. Yeah, so there are these number of elements in the noble gases group or the group 18. We call them noble gases. Why? Because they all exist in the gas or gaseous state. Okay, all of them exist in gaseous state at room temperature pressure. Now, why noble? Okay, they are noble because they are very stable. Why are they very stable? It's because they actually have fully filled electron shells. Look at my diagram here. Okay, helium. Helium actually has got 2 protons. That means it has 2 electrons in an atom of it. Okay, so 2 electrons. And we know first shell, or shall I say first electron shells, can take what? Can take 2 electrons. So that shell is fully filled. We don't require second shell or third shell or any other shells, only 1 electron shell, and it is fully filled. Look at neon. Neon actually has a proton number 10, so 10 protons, and being electrically neutral, it has 10 electrons also. So first shell takes 2 electrons, second shell takes the remaining 8. So this is a total of 10 electrons. First shell is fully filled, second shell is also fully filled. Can see that? So they are stable. So long as the electron shells are fully filled, right, there is no need for the atom to lose or gain electrons. They are very stable already. They are happy on their own, okay? They don't want to form partners with anybody. They want to be alone, okay? So this is something that you got to know. Next, we have argon. Argon has got 18 protons, 18 electrons. So first shell takes 2 electrons, second shell takes 8, third shell takes 8 also. And we know the second and third shell must have 8 electrons to be filled, right? Okay, so all the 3 shells here are fully filled. Now, stable noble gas configuration means what? Means all the electron shells are fully filled. So it also depends on how many electron shells are required for the atom. The first one over here, helium only needs 1 electron shell because it has only 2 electrons, but don't need to have 1 empty shell floating there, no need, it won't appear also. Okay, so next, if you have the neon, okay, neon is definitely like 2.8, and 2.8 means what? Okay, it is already fully filled for this first and the second shell. Does it need a third shell? No, it doesn't. All right, so take note, only noble gases, which is the group 18, all right, have this stable electronic structure. Do you see the word stable appearing? Okay, stable appearing. Now, why is it called stable? Because when the electron shells are fully filled, right, there is no need for the atom to take any electrons or anybody, nor does it need to give it away. Okay, so they are always very stable. Imagine like human being, all of us want to be stable also, right? Do you want to be unstable? You want to be like someone who has like some problem, okay, you always feel like, oh, something is missing, or, you know, or you need to lose weight, etc. They are not, no, the noble gases are so perfect. Yeah, I can see Jensen putting thumbs up. Okay, everybody wants to feel like we are stable, happy, right? Noah. Huh? Jensen doesn't want to Asian or. Okay, all noble gases, Hannah, but we only need to use a few examples to prove that, they are stable because they have electrons shells filled. Now, and I will not go on to more than this, okay, because helium, neon, and argon, right? Okay, we at this level only need to learn up to the first 20 elements. In secondary school, I repeat, you only learn the electronic structures of up to the first 20 elements. How to define the first 20? Look at the proton number. Go up to proton number 20 only. Why is that so? You may be asking, why Miss Tay, why like that? Okay, because if you were to go down further to the next row of elements, right, the rule will change because fourth shell onwards, right, okay, you might not see fully filled electron shells as 8. Okay, it can go to 18, but you don't have to know this because it's complicating. Okay, a bit complicated for you, Hannah. So learn up to only the first 20. Can? The rest, leave it to A levels and so on. If you're still interested in doing chemistry, then okay lah, you can go and read up more on your own. But if you think that you're too stressful for me, no. So what I will advise you is don't read too much yet. Why? Because when you go to Sec 3 and Sec 4, experience chemistry as a subject first, then ask yourself whether it is for you. Some people don't like chemistry. I love chemistry. Okay, so for me, chemistry is the subject I love the best, which is why I chose to teach it. Okay, so when I was training to be a teacher, when I was training to become a teacher in NIE, I actually selected 2 subjects. One is mathematics, one is chemistry. Okay, so I major in 2 subjects actually. Right, so let's go on to the next one. Okay, so first shell fully filled. We call this a duplet structure. There's a term for it. But at your level, do you need to know? No need. Okay, in Sec 1, you don't have to know. You just need to know first shell can take up to 2. Okay, and when it's fully filled, then it's stable. Second and third shell can take up to 8 electrons when these 2 shells are also filled, right? For example, we say that the atom has achieved octet stable electronic configuration. That is for Sec 3, not now. Okay. Is Nikki overseas? Yes, Nikki is overseas. He's in Malaysia. He's returning tomorrow. Yeah. Correct. Can tell, right? Because it looks so different, huh? Yeah. Okay. He's making us jealous, isn't it? The background so nice. Okay, anyway, let's continue. Formation of ions. Why is there a need to form ions? Now, firstly, you must understand how to define ion. You will be asked. Okay, sad to say, Sec 1 and Sec 2, they like to ask definition quite a bit. So they will ask you things like, okay, define an ion. So how do you define it? It's an atom or group of atoms with an electrical charge. So what do I mean by this? Example, okay, sodium. Sodium actually can form an ion with 1 positive charge. This is sodium cation, okay, positive ion. It can also be calcium, which is forming a 2+ charge. These are ions. Okay, so when you see something like that, right, they are telling you these are ions. Can it be negative? Yes, it can be negative. Remember, I told you last week, right? Positive means cations. Okay, then negative called what? Negative ions are called what? Do you still remember? Is it dot ions? Since this one cat, the other one is dot ions? No, it is anions. Correct, Hannah. So anions, example, fluoride, which is a Cl minus. Okay, if you want more negative one, we can have oxygen forming oxide ion. Okay, so chlorine atom can form chloride ion. Oxygen atom can form oxide ion. So when they form ions, they carry electrical charge. Okay, ions carry electrical charge. Always remember this. Now, an ion is formed when atom loses or gains electrons to achieve its stable noble gas configuration. Okay, or we call it the complete electronic configuration. Yes, this is a new set of slides. I'll send it to you all later. You're getting it. Okay, why am I teaching this? Even though this is optional, it seems like all the students, right? Many of you here today or on Monday say that you will be taught this and you'll be tested. Okay, Wednesday group, everyone tested. Hannah, are you tested or not? Your teacher never teach you this part, right? So you listen lah. Okay, it's good knowledge because eventually you will learn this as well. If it's not this year, maybe next year, maybe it's Sec 3, we don't know. Okay, but you still will learn this lah, eventually for O-level sake. Now, so two types of ions, positively charged, we call cations, and then the negatively charged. We really have students who wrote down dot ions, in the exam papers before, because they see that this is cat, then the other one must be opposite lah, dog lah. So they put down dot ions, which is definitely wrong. Okay, so how do we get the cations? Usually, they are the metallic elements from the periodic table. So what are metallic elements in the periodic table? If you look at the periodic table, remember, I shared with you all before. Yeah, lah, sounds like onions. I have students who also spell onions before. So what are the metallic elements? Remember the staircase line that separates the metal from the non-metal? Yeah, that is how you actually get the range of elements that will form cations. And then the non-metals here, they will form what? They will form anions. We don't consider this group here, okay? This group, they are so stable, they don't form ions at all. They are so stable, like the nuns and the monks, right? They don't want any partner. They are happy on their own, that kind. Yeah, Nikki is smiling away. All right. So that's what I do when I teach students about the noble gases. Okay, so back to this. Sodium chloride, remember table salt. It's sodium chloride. It's sodium chloride in terms of the chemical name. Okay, chemical name. Common name will be table salt. Chemical name is sodium chloride. So how does sodium chloride actually look like? Okay, they have a diagram here. So you have the positive ions and the negative ions arranged in this way. Okay, they are really arranged in that manner, one positive, one negative, one positive, one negative, like that. Right, so they are made up of two different types of ions, sodium and chloride. Okay, Na plus and Cl minus. Now, how is this sodium ion formed? So let's look at sodium. Okay, sodium in the periodic table, it falls under group 1. All right, it is in period 3. You can also look at the proton number, which is 11. Can locate your sodium now in the periodic table. Okay, Nikki, if you cannot, don't worry, Nikki. I know you got only one screen to work with. You don't have anything else with you, right? Not to worry. Okay, so sodium actually look like this. If I were to copy what I see in the periodic table, there's an 11 here. Then they write down the name for sodium, and then 23 is at the bottom. Now, whenever we do electronic structure, wrong. Okay, whenever we do electronic structure, we are only more or less interested in the number of protons. Yeah, number of protons. Why? Because it will tell us the number of electrons. So, sodium atom. Okay, last lesson, we also learned how to draw all this, isn't it? So the first shell can take 2 electrons, second shell can take up to 8, and then the third shell can take 1 electron, which is the last electron left. After you fill the first and the second shell with electrons, right? What is left is only 1 electron. Okay, 1 electron is placed in the third shell. But one problem here. Sodium having 3 electron shells, right? And then the third shell is not fully filled, right? It can take up to 8, isn't it? But there's only 1 now. So it makes sodium extremely unstable. Okay, only fully filled electron shells